All right, here we have a scenario where we're see if we can splice some kinematics and dynamics and momentum type ideas typed together. You could do this question in a few different ways, but we'll try and see if we can splice a few things together here to show how things actually connect or can connect. Basically, you have a car that was going 16 meters per second and it hit a brick wall outside a building, and of course the car got squished 70 centimeters. And the car has a mass of 2,800 kilograms, and we are going to find out how much force actually stopped the car when it hit the wall. And there's a few ways we could do this, but we'll see if we can sort of mix a few things together and see what we can do. Now, first things first, I'm just going to look at my speeds. I know the car was going 16 meters per second when it hit the wall. Obviously, after it hits the wall, it's going 0 meters per second. So my change in V is negative 16, my average V would be 8, and these quantities can come in handy. I often like to lay out my V's just to see what I have going on in case I need them for anything. Now, when I look at my quantities, I've got a distance over here, and with distance and an average V, I can find out time. So if I do my basic DTV, so time is equal to distance divided by average V, I've got a distance of 70 centimeters, but we have to put that into meters, and I've got the average V of 8. I can divide the two out to find how long it took to stop the car. And that gives me approximately 0.0875 seconds. So now I have the time it took to stop the vehicle. Now I could then use this time to find acceleration. I could use that to find F equals ma. There's a couple things I can do with that, but we're going to try and do something a little bit different. I also know that the car has the mass, and it came in at 16. So with its mass and its V that it came in at, I can actually find out how much momentum the car actually had. So if I want to find out the momentum is just going to be equal to m times V, and I'm going to use the 16 for that to find how much momentum it had when it came in. And that gives me approximately 44,800 kilogram meters per second momentum, which is how much momentum the car came in with, and then it hit the wall. So if that's momentum it came in with, and then the wall stopped it, that's how much momentum it lost. So the impulse for the car would be negative 44,800, because it went from 44,800 all the way down to 0. It lost it, so the impulse would be negative 44,800. Now that I have the impulse and I have the time as well, force is impulse divided by time. So I have the impulse of 44,800. I've also got the time I found before using my DTV. So I can take that 44,800 and I can divide that by the 0.0875 seconds. And that would give me about 512,000 newtons. And I'm going to call that a negative force because it is slowing the car down, is stopping the car. So we're going to say negative 512,000 newtons to stop the car when it hit the wall. Now again, you could have used the actual change in V, the negative 16, divided by the time that we found over here in order to find the acceleration to then find the force, but this is another way to do it as well.